Hello everyone, my name is Laurette Fourie and that is Qwanita. Thank you for joining us and watching our presentation on bridging theory and practice, utilizing AI and 3D printing in higher education.
Now let's look at the emerging technologies in education. The first one is AI. Now AI can make education more accessible, it can drive innovation and problem solving. If we look at 3D printing, it can assist students to create tangible models, it can foster creativity and hands-on learning, it can help students to a better understanding of complex structures and concepts. Now, if we merge these two together, we will enhance learning experiences and practical applications.
Well, I'm sure that many of you are thinking, wonderful, AI and 3D printing, but how did your journey start? Well, my husband purchased a 3D printer and introduced me to Thingiverse. Here you can find thousands of 3D printable items. And of course, as a math and science lecturer, I immediately looked for related items to print. Time went by and in NS, I had to teach the Bohr diagram and the Lewis dot structure. Now, remembering that last year the students battled with it, I went onto Thingiverse and found this. So I was printing, found more things to print, and the result was, yes, I'm sure you've guessed it, my own printer. So in a sense, I feel that this research was done a little back to front. First, we had an idea, implemented the idea, saw a difference, and then matched the theoretical framework and methodology.
Now, how did we go about integrating these technologies in our lessons? The two of us saw the value of integrating AI bots and 3D printing in our lessons, and we've printed physical manipulatives of abstract concepts. Now, the first thing we did was we used AI. We went to magicschool.ai and we asked it to develop and create some questions on a relevant topic. The second thing we did was bot integration. We took the questions that we got from magicschool.ai and we compiled the questions in the bot. The bot that we used was LandBot, and more on what the bot did a little bit later on. The third thing we did was 3D printing. We went and we looked for abstract concepts. We printed that for the students to use during their activity. And the 3D printer that we used was the Creality K1C. Now we're going to explain to you the process we used for these three in our one activity.
So how did it look? Over here you can see this is Magic School AI. We used this to create a few questions and then we built on it. This is the bot that we used, but more specifically, LandBot. This was used where the lecturer is a facilitator and the students take control of their own learning for this activity. In two of these steps, which you can see where the arrows are showing, the students had to upload an image of their Bohr diagram and Lewis dot structure. From the submissions in the bot, images were saved onto a Google spreadsheet where the lecturer can click and view on the images. This can also assist in keeping track of participation, and where you see the open spaces, you can clearly see which student was absent for this activity. Using the Bohr and the Lewis 3D printed manipulatives, theory was done first and then changed into a more creative and hands-on approach. In the photo on the left and right, you can see the images that were submitted in the bot. Now, what are the costs? The initial setup of the 3D printer, which is approximately $830, and one roll of PLA filament, which is approximately $19. Now, these two items cannot be purchased in a shop. And this abstract concept, like the valence electrons, were made visual and concrete using 3D printed manipulatives. In the below table, you can see how much it cost me to print every single element of the Lewis dot structure and the Bohr diagram.
Where are we now? Many of you might ask, listen, now you've done a couple of these things, what now? Now, since we've started with our research, what we have noticed, we have printed many more 3D manipulatives. We have also branched this out to the math department for them to use. And our end goal is to have students come in, print their own teaching manipulatives that they can use during their teaching practice, or once when they are qualified teachers to use it in their classes to ensure quality education. Let's quickly highlight what we have found in literature to be the role of AI in math, science and technology. And we have even seen this in our own lectures when we have done and incorporated AI. The first thing is, in mathematics, it helps students grasp complex concepts through step-by-step problem solving. In science, it makes challenging concepts more accessible and engaging. If we look at the previous examples that we showed about the Bohr and Lewis dot diagrams that we had 3D printed, many of our students do not and never had the chance of learning through concrete manipulatives. So what we did was something that's very abstract. We 3D printed it, we gave it to them, and that difficult abstract concept that they've always struggled with understanding, they understand a lot better now, doing it through concrete manipulatives. And in technology, it allows students to understand the real-world applications of AI technologies that are out there. If we think about it, AI and technology is there. It's there to stay. And what we need to do is to make sure that our students are ready for the world of work. We are making sure that the teachers we are teaching will be the best in their fields one day, with the best education and the best relevant knowledge out there. Autoethnography is the methodology that we chose because it's from our personal experiences and point of views. We saw a need and we wanted to fill it, and we wanted to know whether or not this will help students or not. And we saw that bringing in different types of technologies into our classrooms actually assists students. So from our personal experience, we have seen such a growth point in our students by just making sure that we bring in new things into the classrooms.
Our theoretical framework lies within the constructivist learning theory, accompanied by the universal design for learning, focusing on hands-on engagement and multiple representation. In one lecture, I had more students physically in front of me than what was on the attendance register. Now, I keep telling myself that the word got out regarding the 3D printed manipulatives that I use in lectures. Very interesting questions were asked during these lessons, and many students wanted their own printed manipulatives. And also very interesting that 96.2% of students received full marks for the Bohr diagram and the Lewis dot structure question they received in the exam.
While we did this research, we saw some opportunities, we saw some things that we had to consider, and we noticed some challenges. Now, what opportunities did we notice? That including AI, 3D printing and any other technology can enhance learning. It can assist students to build their teacher toolkit, which can help them to prepare for their workforce one day. It can also assist them to understand abstract concepts a lot better. Things we had to consider and take into consideration: we had to expose them to new technology and make sure that it's still relevant for the world of work. We also had to make sure bots for guided training, that we understand how can bots be used to guide learning, and then expose our students to this so that in future they can learn how to do it and use it in their classes. We also had to consider which manipulatives will be necessary for us to incorporate into our lessons, because as we all know, in South Africa, or I don't know how many of you know, in South Africa not all schools have the relevant manipulatives. So which manipulatives do we need to start incorporating, start printing for our students to use in their toolkits one day? Some challenges we saw: costs. Now, it's like any other thing. Startup costs are normally big, but as soon as you have it and you have all your filaments in the machines and the software and the subscriptions, it will go better. So startup costs are expensive. Outdated software can be a problem. Maintenance, skills, and accessibility. But what we need to make sure is, and what we need to remember is, even though the startup cost might be a lot, in the long run, if one small particle in your manipulative breaks, you can 3D print it again, and do you not have to go and rebuy the whole manipulative from a company.
A special thanks to Mr. Etienne Fourie for the use of his 3D printer and his subscription to LandBot. Thank you very much for watching our presentation regarding the integration of AI and 3D printing into higher education.